So I'm just going to turn this over to Jim and we can get started.
Great. Thank you, Marie, and appreciate the opportunity to present to your customers today. And thanks, everyone, for joining us. My name is Jim Ralston. I'm Director of Channel Sales with Softing here in North America. And we also have on the line Tom Jallo, who is our Director of Customer Service Support, who's one of the experts in the industry on Ethernet cable troubleshooting and diagnostics. Just real briefly, Softing, we're a German-based technology company, globally focused in a number of different product lines and technologies, and a very close partner with Siemens and the Siemens ecosystems, which is why we have a good relationship with Applied Controls, who's an active distributor of ours out there in Eastern Pennsylvania. I'm based in Pittsburgh, Pennsylvania, but I used to say I travel all the time, but I haven't traveled much in a year and a half. Hopefully that'll change soon. And then Knoxville, Tennessee is our North American headquarters, and that's where Tom is located. So today what we're going to go over is a little background on what makes industrial Ethernet networks, industrial networks unique, especially relative to commercial installations. And so that's unique both from a challenge and a risk perspective. Talk about some of the layer 1 and layer 2 testing scenarios, including what's known as IEEE qualification, which is actually doing a bit error rate speed test over the cabling as a way to confirm operability or if there's issues, help in troubleshooting. Then talk about some best practices in general for industrial network testing. And we have a particular tool that we offer called the NetXpert XG, which is very well positioned as kind of a all-in-one Swiss Army knife tool, although they don't like me saying Swiss Army knife since we're German. But actually very well positioned for doing industrial network troubleshooting, practical tool for folks in the plant. Also a very practical tool for contractors or system integrators. And then I'll walk through a number of the cable testing slides that we have with the NetXpert XG. And then if the Microsoft Teams God is happy with us, Tom Jallo can actually present a live demo of doing some fiber testing with one of our testers that he has there in Knoxville. So anyway, and then we'll open up to questions towards the end. I should also say, I think, is Steve Arnold on the line with us, Marie?
I don't see him on.
Okay, yes, I'm here.
Okay. Thanks for joining us, Steve. So we work closely with Steve at Applied, who actually has a couple of our demo testers and is a networks expert. So we appreciate his support. So he's a resource for you all out there. So anyway, just a little background, industrial networks, unique challenges and risks. So industrial Ethernet, I've been in the industrial network industry for about 20 plus years now. So obviously industrial Ethernet is well accepted and deployed and used extensively and growing. Certainly, all the automation suppliers, including Siemens with Profinet, has firmly embraced it. Lots of different applications for it, as you all know, I'm sure, machines and robotics, control automation, getting data between, from the plant floor to the IT systems or, layer 3 systems like MES. A lot of focus now on data collection, right? And then there's also process monitoring and vision systems. And these all these systems can use or rely on, that industrial Ethernet foundation. So it is the industrial backbone, right? For the network. And so a lot is riding on it, right? So if there are intermittent problems or any kind of problems with an industrial Ethernet network, that is a huge productivity, profitability killer because of the high cost of downtime, in these production facilities. And, we've heard things like in the automotive market, which we, service predominantly in Detroit and the southern states, 1 minute of downtime can be $20,000, right? So the clock is ticking when there's issues and when there's glitches, right? Ethernet cabling in industrial plants is, the architecture, the structured network design for those can be quite different than commercial, where there's a lot of quote home runs, long Ethernet cable runs with plugs on the ends. Most of the commercial focused installation steps and guidelines all follow more of there's an outlet on the wall, there's a patch panel somewhere in a closet with a Ethernet port, outlet on it, right? And so a lot of the certification and installation rules are all based on that, whereas with industrial, it's kind of Pandora's box, right? So obviously one of the major differences too with industrial plants versus commercial buildings is high noise, right? Interference, EMI, RFI. That's definitely something that sets it apart and necessitates the need for shielded cable, using shielded cable, and that is a testing that, improving, that there are or are not interference problems can be a major challenge. And then finally, I mentioned on this slide too, TIA 568. So this is not TIA Siemens. This is TIA from the TIA group that has all the specifications for Ethernet cabling. So like Cat 5, Cat 6, Cat 6A. The TIA 568 group has all the standards and specifications for, how to design cables to meet it and how to install, and also how to certify and test. So there's a lot of certification rules in place, and we as a supplier, have an offering that tools that do certify an Ethernet installation as a way to prove that the installer did their job. But that's not always enough with industrial. It's good practice for sure, but it is rarely done. Number one, in our experience with industrial networks, though so much is riding on it. But even if it is done, it's not necessarily telling the full story behind if the cabling is going to meet the system requirements or not. I also threw this slide into ISA had an interesting study of a couple years ago where they asked their members, what are the causes of network failures, right? And from an industrial perspective. And when you look at this pyramid here, over 70% of the issues were related to layer 1 and layer 2. And what is layer 1? The physical cabling, right? The Ethernet cables, copper fiber. Excuse me. What is the data link layer? What is layer 2? Well, that's the data link layer, the basic connection to the switches. So 70% of the time, more or less, and when we talk anecdotally, with our the customers we deal with all the time, some of them say 90% of the time that there's a network issue. It's usually because of the cabling, right? So again, this is where it's very good to focus on from an industrial troubleshooting perspective, and that leads us to talking a little more deeper on what qualification is. So in the Ethernet standards, as I mentioned earlier, certification is having a tool that essentially says the cabling was terminated properly. It's the proper length. It can support a certain frequency over the cable, which equates to a certain speed of the cable. But it's also often done at the beginning, when things have been installed, not when things start up and machines turn on and interference is encountered in the network. So qualification, on the other hand, is actually doing a speed test, a bit error rate test over the cable, preferably at startup or during operations as a troubleshooting method, to show that the cable can independently support the speed of the network. 10 megabits per second has been around a long time. Systems have progressed to 100 meg. There's more and more systems, industrial systems, running at 1 gig. 10 gig is not that far around the corner, right? So how do you know that your cabling can support those speeds, especially in high noise environments? Doing a qualification test, a bit error rate test, is a great way to prove that, and also an invaluable tool for troubleshooting. These types of tests is much more in depth than just looking at DC continuity, which a lot of the low end testers do. That's the other end of the spectrum, is, hey, does pin 1 go to 1? Does 8 go to 8, right? So having the means to do speed testing over the cable is really good practice for industrial settings. And what can cause errors? Well, I've already talked about interference, and that could be, motors and drives and arc welding and high voltage lines, cables too close, fluorescent lighting. Maybe the cable is, going beyond its limits. Maybe it's an older cable that they're trying to push to run a higher speed. So not necessarily EMI issues, maybe just the cable's not up to spec. Poor termination, and then cable shielding issues. So there are different grades of shields used with cable. That you can have a low end shielded cable, you can have a high end shielded cable, and yes, that does matter. So those are all causes of that. So let's talk a little more specifically about what an ideal industrial network Ethernet testing tool has, what characteristics. And again, we're focused on that layer 1, layer 2, where most of the problems are oriented. Portable, rugged, right, for the industrial user, the maintenance person, the integrator, the engineer. It provides a quick means to test, copper cabling and fiber optic cabling to kind of at the high level, a pass fail. Is the cable good or not? And if not, how do we fix it? What's distance default, etc. Easy to use. You don't need to be an IT, Cisco certified technician, or a RCDD per se, which is another level of certification, training, and testing. Provides the distance default I mentioned earlier as a way to quickly fix the network and get it up and running. Includes qualification, so not just lighting lights to show continuity, but doing an actual speed, IEEE speed qualification. And then some handy layer 2 tests, right? So, and by handy, have a group of tests that can tell you quickly connectivity to devices, if there's any configuration issues with the switches, speeds are set in correctly, etc. VLAN settings can also provide some insight in if there's latency. Those are all handy to have. And then we also see a big trend in the industry, and commercial for sure, and this is getting more into industrial, of actually using the Ethernet switches to power devices. That's called PoE, Power over Ethernet. And so PoE becoming more popular. How do you know the switch is putting out enough power? That's a great test to include as well. And then finally, it's good in, with this type of level tester to have a means to produce reports. If you're an integrator, working on a system with your customer, that's a good way to communicate with their IT, support team or their contractors to have some formalized reports. It's also very nice if you're an end user to document things, and as you do your tests up front, to have a good snapshot, a baseline of what the network looks like, what the cable performance is, and then you can compare that in the future with reporting functions. So our NetXpert XG, of course, meets all these requirements. It was engineered and designed to be, much more than a cable, wire continuity checker, but not a high-end certifier, which has its own place but is different in that realm of providing very functional, practical tools to quickly fix problems. So our NetXpert XG portable touchscreen, large touchscreen, so easy to use, has qualification testing, passive cable testing with distance default, the ability to do active layer 2 network testing, test power over Ethernet, and then also has the option for fiber optic testing, which hopefully we'll be able to see a live demo of that in a few minutes. So I wanted to show you just a few sample screens of what you see on the display of our XG. And this is one of the basic ones, which is showing a quick test of a cable from end to end. So if you think you're having a problem with the cable, you can easily attach the XG. We have a remote unit. I showed it the earlier slide. And then the main unit, which has, where you quickly choose what test you want to run. And then within, 15, 20 seconds, you get a nice screen that shows you the length of the cable, if there's any wiring issues, opens and shorts, distance default, is the shield connected or not, right? And if there's a problem with interference or noise, that can show up one of two ways. We do a signal to noise ratio measurement of the cable, and we also do that bit error rate test. And the XG is capable of going all the way up to 10 gig. 1 gig is more common in the industrial market, but it is 10 gig ready for if you happen to also service the commercial side. We do have optional M12 test kits for it too, test adapters. So M12's the watertight connector. So it's handy to be able to test and troubleshoot that as well. The bit error rate test, I've already mentioned this several times. This is a vital test because this is the way to confirm or not that there might be interference problems. I mentioned earlier as well, sometimes problems can be intermittent, the kind of the gremlins in the network. So we have some means and ways to do continuous testing. But I wanted to point out an actual field test I performed with a water district down in Florida. Oh boy, I guess it was well over a year ago now. Time flies. Anyway, this is an interesting story because this this is not the exception, I believe. So this particular water district, they were having problems with the timeout of a pumping system on one of their large water tanks, and it had been intermittently failing for over a year. Now they had a backup to it, but the backup would keep coming on, and it just wasn't ideal at all, right? They had dispatched the integrator, they had their IT people look at it, just could not find a reason for the timeouts. So I went in with our NetXpert XG, with our distributor down there, opened up the panel. That's a real photo of it, and it was like, okay, there's a fiber optic router connection here. There's a large drive, and there was an Ethernet cable that was that started here and ended up down there. So I put our tester, our XG, on that cable just to see what the results would be. And lo and behold, 15-bit errors. So, even though the distance was 2 feet, well, that cable was actually like 18, 19 feet long. So, it was coiled up somewhere in the back. It was a shielded cable, as you can see, but it was picking up interference. It was, and the test results showed that though the cable passed the wire test, it did not pass the 1 gig test for bit errors. So this was an indication that though the cable was shielded, it wasn't shielded enough, or the shield was damaged somewhere in it. And after a year of problems, they replaced it with a higher grade shielded cable, and that fixed the issue of that pump station going offline. So I point this out because all their other test gear and the folks that tested that cable, everyone confirmed that, well, it's not the cable. We ruled it out. It must be something else. Well, what could it be? Well, 1,000 different things. No, it was the cable. They just didn't apply the right test to it, which is the bit error rate test. So I like to emphasize that because that happens more often than not in the industrial environment, especially in industries where there's a lot of noise, like drives, picking up harmonics there, right? Let's see. So I mentioned just a minute ago too about intermittent issues where you may have failures over time. That could be as cables get flexed or things, that there's a lot of vibration, robots, overhead cranes, things like that, or maybe some fluctuation in equipment running over time depending on time of day. So we also have some really handy test modes in the XG for doing continuous testing of the cable. Both bit error rates and also wire maps. So this makes it easy then to do as a way to set it up and let it run over time, some period of time, and then go back and see if there was problems and detect the intermittent issues that way. So that's a good dive into, or an overview of the copper testing modes. Before we get into fiber optics, I'm going to talk about some of our layer 2 tests, and I'll kind of go over these quickly and maybe tell you a story or two. But anyway, there are built into the XG a number of handy tests for layer 2. Link status, which will tell you what you're connected to, what the XG is connected to, what the switch is configured for, what speed it connected, PoE testing, the ability to get a IP address from a DHCP server if there's one there, network discovery, a way to do a quick scan of what's active, ping tests, some layer managed switch tests for CDP and LLDP, and I'll go over a few of these in detail that are relevant. Trace route, VLAN detection, simple thing like flashing the link light on an Ethernet switch so you know which cable to disconnect. These are all additional tools built into the basic XG. One of the most handy ones is being able to do a quick scan of the network and detect all the IP addresses and MAC addresses that are present. So if you're there's a certain range of addresses that you should be able to reach, and those aren't coming up, that's a red flag. Also, our XG is very good at detecting duplicate IP addresses, which happens more often than not than it should. That can cause all kinds of issues. So there's a quick sanity check about IP addresses. And I did have one particular customer in Ohio, a container producer, plastic container. And I went in and did a demo for them, and they allowed me to connect up to their industrial switch. And we ran a test like this, and boom, 3 duplicate addresses came up. And I was like, I think you guys might have a problem. And the maintenance guys there were like, we told IT we've had an issue and they just don't support us well. Well, they bought it on the spot because this gave them the evidence to talk to their IT group and say, hey, we're seeing this and what's going on, right? So anyway, that's another real life story. So pinging. So we all know, or most of us know, hey, I can always set up a ping test from my computer. That's a basic DOS command. The XG makes it really handy because you could take all of the or any of those addresses that it detected and put it into a ping table and then ping it continuously, reporting the results in real time on the screen there. So you get the minimum IP or minimum ping response time, the maximum and an average. So this is really a basic but nice way to quickly see if there's intermittent problems reaching certain devices or some latency issues. And this report, as all the reports I failed to mention earlier, by the way, you can save as this test and all the other tests I mentioned, you can save as a report. This one you can save as an CSV file for Excel. So it makes a really nice way to document ping latency issues. We also do with the XG a means to do trace route testing, so you can see the delays and getting through a router and where there may be some latency issues there. LLDP and CDP, these are the managed switch protocols. So you can utilize this with CDP, which is all Cisco switches support that. LLDP is kind of the more generic version, and be able to sniff and find out how the switch is configured, firmware rev of it, what port you're connected to, even information like where it's located. That's very handy information. And then I've mentioned a couple times as well, PoE, power over Ethernet. PoE is roughly 48 volts, assigned over a couple of the pins. There's a lot of different PoE standards. So one of the things the XG will do is report or detect PoE on the switch. It will tell you what standard it is, what wattage rating that standard supports, and do an actual load test and report the real voltage levels. Ethernet switches that support PoE have certain budgets, so it's not like if you have a 24 port PoE switch, every port's going to provide the same level of wattage. You have a budget. And then of course the question is, what if it's faulty, right? How would you measure it? How would you know if it's not putting out enough power? Well, again, this is a very handy test that the XG provides. So at this time, we are going to transition into a discussion on doing fiber optic testing. And I'll just ask Tom, are you able to share your screen? Are you on with us?
Yes, I am. I can share my screen, just one moment.
Very good.
There we go. Can you see that, Jim?
I can. That's great. Thanks.
Excellent. Okay, so the XG, as Jim mentioned, has the ability to test fiber optic links, as well as test networks in the same way that Jim's already discussed over fiber optic connections. So in other words, it can connect to a switch and perform the active network testing that Jim mentioned over fiber. LLDP, it can pull a DHCP or a static address and communicate with the switch and perform those various test functions. But unique to XG is the ability to qualify a fiber link. So I have two XGs in front of me here. Let me plug here. This is the XG itself, so you can get an idea of how it looks in my hands. I have fairly big hands, so you can get an idea of the size of the device. Pretty wide touch screen here, fully interactive screen. There's no other buttons on the device besides the power button here. At the top of the tester, there is a few test ports here, charge port, USB for various USB functionality. And then we have a replaceable RJ45 test jack. Okay, so if the test jack is damaged, you can replace it with another and don't have to worry about your tester becoming useless if there is damage to the RJ45. Then we have two SFP transceiver bays. Okay, so SFPs are the little fiber optic transceivers which fiber optic industry has kind of adopted as the go-to standard here. And we have an SFP, a standard SFP bay, which is for 1 gig communications. And then we have an SFP plus bay, which is for 10 gig communications. Both these testers are licensed for 10 gig as well. And I have 2 testers here, and our idea here, or what we're trying to do, is we want to know if this fiber optic link can work at 10 gig speeds. Okay, so let me go ahead and let's a little bit of juggling here, but let's go ahead and plug in an SFP into the bay. Let's do that over here first. The first thing we want to do is we want to identify if this SFP is the right SFP. There's many different varieties of these, right? Is it capable of 10 gig? Is it multi-mode? Is it working? Let's find out. So I'm going to plug this into the tester. I'm going to go to settings, and I'm going to jump over to hardware. Same thing on this side. I'm going to go to settings, and I'm going to jump over to hardware. And you can see that has already populated in that SFP plus hardware area, and it's giving me all kinds of useful information already. It's telling me that that is a multi-mode SFP there at the bottom. It's telling me that it has a bit rate capable of 10,300 megabytes a second. That's 10 gigs, right? And both of those match. So there's also, you know, serial numbers of the SFP, model numbers, all that kind of stuff. That's also useful. But on paper, at least, these SFPs should work for 10 gig. That's kind of step 1 there, right? Let's jump back out. Let's set up a test real quick. So I'm going to jump into the cable testing section of the XG, and I'm going to go in and we're going to make sure that we've got a 10 gig or an OM3 10 gig fiber selected. So there it is. Let's set that as our current type. You can see there's multiple types of fiber in there, and there's also copper if we were doing copper testing, and you can create custom cable types in there. You'll notice how quickly or how responsive the XG screen is as well. It's nice and fast. Nice crisp operating system in there. So let's pull up a new test. There's a blank test to be performed. On the other side of the tester, I'm just going to take this unit and I'm going to go into remote mode. Now I'm going to grab a couple patch cords real quick, and I'll just show you the ease of use. Not only am I going to test this fiber, but I'm also just going to set a reference. The reason why I'm showing you this is because if you or your customers have ever tested fiber in any way, they're probably pretty disappointed in, or not disappointed, but maybe apprehensive about the amount of work that it takes to test fiber. There's a procedure called a set reference procedure, which can be very difficult or confusing for the customer. We have a set reference procedure on the XG, and it's really very simple. You can see I've just set up a couple patch cords here, linked it together. Let's go and choose set reference, and it gives you a little animation diagram here telling you how to set up the cords. You can see the SFPs going into the tester, which we've already done. It shows a couple patch cords connected, shows it to link, and that's what we've already done, right? And let's just choose set reference. The point I'm making on this set reference procedure with the XG is it is incredibly simple. It's very straightforward. So somebody who doesn't have fiber optic training really at all can go and use the XG and feel confident in its work. And I've already passed the set reference. So if we were talking a different fiber optic tool really of any type, we would still be talking about the theory and what you're trying to do and the procedures and stuff involved in setting reference. And we've already finished setting reference on the XG. So I'm going to jump now over to cable test, or back to cable test. And I'm going to bring in this link. Remember, we want to test this link to see if it is 10 gig capable. So I'm going to connect it between my reference cords here. And let's test. I'm just going to go to my local unit here. I'm going to tap the test button and it'll be off and running. And you can see the other unit's going to kind of talk back to it and say, yes, I'm connected, and you're up and running. You'll then get an animation on the screen that's showing this bit error rate test. So what Jim has talked about during this session that we do on copper and in other situations with the XG, we also do over fiber, and it makes sense. Bits of data is what all of these networks are concerned with. They're not really concerned about fiber optic loss or anything else as far as copper cabling. They're really worried about the data. And that's what we're looking at with that bit error rate test. It really is the most important factor in this cabling. So that's what we're doing here. And for a 10 gig fiber optic link, you have to push around 80 million bits of data on both fiber 1 and fiber 2. And then that's what we're going to do over about 40 seconds or so here to work through this. And if any of those packets of data are lost or dropped, misplaced in any way, then it's not going to be a passing 10 gig link. Now, because we did an additional set reference that you saw at the beginning and did a calculation of what these SFPs are capable of and set referenced with those patch cords, we're going to get some additional information, which I'll show you in a moment, on top of that BERT